Have you ever pondered about the invisible laws that govern our universe? Hidden beneath the grandeur of the stars, the silence of space, and the dance of celestial bodies, exist unseen rules that dictate the very fabric of existence. These are the laws of the universe, the silent puppeteers that choreograph the cosmic ballet. Imagine the universe as an intricate clockwork. Each cog, each wheel, each tiny movement is governed by these unseen laws. They are the architects of every sunrise and sunset, the masterminds behind the changing seasons, and the conductors of the symphony of galaxies that twirl in the great cosmic dance. Now, what if we told you that we could peek behind the curtain to understand these unseen forces? Well, throughout this journey, we'll be exploring some of these mysterious laws that have been unwrapped by the curious minds of our species. We'll venture into the realms of the laws of motion, the invisible threads that bind us to the earth and allow us to vault into the skies. We'll delve into the law of universal gravitation, the unseen force that keeps our feet firmly planted on the ground and dictates the orbits of celestial bodies. We'll explore the laws of thermodynamics, the principles that govern the very flow of energy and the inevitable march towards entropy. We'll delve into Einstein's theory of relativity, a theory that reshaped our understanding of space and time. And finally, we'll step into the strange and counterintuitive world of quantum mechanics, a realm where particles can exist in multiple places at once, and the simple act of observing can change the outcome. These are but a few of the unseen laws that govern our universe, each one an invisible force, a whisper in the grand cosmic choir, a hidden truth waiting to be discovered. And it is through the relentless pursuit of knowledge and understanding that we have begun to unravel these secrets. The journey of discovery through centuries has brought us these hidden truths. Let's continue this voyage together into the heart of the cosmos and the laws that govern the unseen. What we see today as facts were once profound mysteries. The first to be unraveled were the laws of motion. In the late 17th century, an apple fell from a tree in England, sparking the curiosity of a young man named Isaac Newton. This seemingly ordinary event led Newton to formulate the laws of motion, the building blocks of classical physics that would forever transform our understanding of the universe. The first law, often referred to as the law of inertia, states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted on by an external force. Picture a football on a field. It will remain still until a player kicks it, sending it soaring through the air, but even then it doesn't go on forever. It eventually slows down and stops. Why? Because of forces like gravity and air resistance. Newton's second law of motion takes us a step further. It tells us that the force acting on an object is equal to the mass of that object, multiplied by its acceleration. In simpler terms, the heavier the object, the more force you need to move it. Think of trying to push a car compared to pushing a bicycle. The third law, perhaps the most famous, tells us that for every action, there is an equal and opposite reaction. If you've ever jumped off a small boat, you've experienced this law firsthand. As you jump forward, the boat moves backward. These three laws, seemingly simple, laid the groundwork for much of the physical universe as we understand it today. They explain everything from why we don't fly off the Earth as it spins, to how rockets can travel in space. And though they've been refined and expanded upon by later theories, their basic principles remain as true today as they were over 300 years ago. Newton's laws of motion, the first stepping stones in our understanding of the universe. Following the laws of motion, another law emerged from the mind of the same genius, the law of universal gravitation. This law, sprung from the brilliant mind of Sir Isaac Newton, is a testament to the interconnectedness of the universe. It tells us that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. In simpler terms, it's the reason an apple falls from a tree straight down and not sideways. It's the reason why we walk on the Earth and not float aimlessly in the air. It's the glue that holds the moon in orbit around the Earth, the Earth around the Sun, and our entire galaxy together. So, next time you feel the weight of the world on your shoulders, remember, it's just gravity doing its job. Gravity, the unseen force that keeps us grounded, literally and figuratively. Fast forward to the 19th century, the laws of thermodynamics came into the picture. We're entering an era where the concepts of heat, energy, and entropy became paramount. It's the era of thermodynamics, a field grounded in three fundamental laws that govern the universe's behavior. The first law of thermodynamics, also known as the law of energy conservation, is quite straightforward. It tells us that energy cannot be created or destroyed, only transferred or transformed. When you light a match, the chemical energy stored in it is converted to heat and light energy. That energy didn't magically appear, nor will it vanish into thin air. It merely changed forms. Next, we have the second law of thermodynamics, which introduces a less familiar concept, entropy. This law states that the entropy of an isolated system always increases over time. Entropy is a measure of disorder or randomness. It's like a cosmic rule for tidiness. Left to itself, a system will always tend towards disorder. Think of it as a teenager's bedroom. No matter how many times you tidy it up, it always seems to end up in chaos again. Finally, we have the third law of thermodynamics. This law states that as a system approaches absolute zero, all processes cease, and the entropy of the system reaches a minimum value. This is a theoretical state, as absolute zero is impossible to achieve. Yet it's fascinating to think of a state where everything stands still and disorder is at its lowest. These three laws of thermodynamics govern how heat, energy, and entropy behave. They are a testament to the universal truth that nothing is lost or gained. Everything changes, and disorder is an inevitable part of existence. The laws of thermodynamics governing the flow of energy and the inevitable march towards disorder. The 20th century brought forth two groundbreaking theories, Einstein's theory of relativity and quantum mechanics. Picture the universe, vast and endless. Now, imagine trying to explain its workings. This was the task Albert Einstein undertook when he proposed his theory of relativity at the beginning of the 20th century. This theory, in essence, revolutionized our understanding of space and time. It asserted that space and time are not separate entities, but are interwoven into a single continuum known as spacetime. Imagine a sheet of fabric stretched taut. If you place a heavy object on it, the fabric bends. This is how Einstein described gravity, not as a force, but as the bending of spacetime caused by mass and energy. Now, let's shift our gaze from the cosmic expanse to the incredibly minute. This is where quantum mechanics comes into play. Quantum mechanics is the science of the tiny, the realm of atoms and subatomic particles. It's a world where particles can exist in multiple places at once, where they can be both particles and waves, and where observing a particle can change its state. Yes, it sounds strange, even counterintuitive, but the quantum world doesn't play by our everyday rules. It has its own set of rules, rules that have been experimentally confirmed time and time again. If you are interested in learning more about the quantum realm, click the link above or in the description box below to watch our previous video, The Odd Realm of the Quantum Field. Now, Einstein's theory of relativity gave us a new understanding of the large-scale structure of the universe, while quantum mechanics revealed the bizarre and fascinating rules that govern the smallest particles in the universe. These two theories, as different as they are, both emerge from the same desire to understand and explain the workings of our universe. In the grand tapestry of modern physics, relativity and quantum mechanics are inseparable. They are the twin pillars that hold up our current understanding of the universe, each contributing a crucial piece to the cosmic puzzle. Relativity and quantum mechanics, the twin pillars of modern physics, reshaping our understanding of the universe. These laws, discovered over centuries, continue to guide our exploration of the cosmos. They are the unseen forces at play, the silent directors of the grand cosmic theater. From the dawn of discovery, we've unearthed and understood a series of these laws. Gravity, that invisible force, keeping us grounded, and the planets in their celestial waltz. Then, We delved into the realms of heat, energy, and entropy, unmasking the undercurrents of chaos and order. Continuing our journey, we crossed paths with relativity and quantum mechanics, two seemingly contrasting theories that have revolutionized our perception of space and time. These discoveries were not mere happenstance. They were the fruits of relentless curiosity, unyielding determination, and the audacity to question the apparent. They are the compass guiding our exploration and the map to our understanding of the universe. The laws of the universe are keys to understanding the cosmic dance of celestial bodies and particles alike.